Today we're going to look at finding limits graphically. The good thing about this is it's really fast because you're just looking at a graph and finding the answer. But it can get confusing. This is one of those things, like it can be confusing at first, but once you've got it, you've got it. And you're probably going to think it's super easy once you finally get it. But don't worry if it seems confusing at first. Just keep trying and you'll get there. So a few just notation sort of things. If I find f of 3, that means the y value of the function when x equals 3. So basically you're just plugging 3 in, and that's going to give you the y value that goes with that point there. So it's the point on the graph. It is not a limit. It is just that point. If you see the limit of f of x, and below it you see this x with the arrow and a 3 and a plus behind it, that means the limit from the right. Which I use that notation a little bit in those notes that you were looking at on Friday. So if it was from the right, you picked the numbers that were bigger than whatever number it was, and you got closer and closer and closer this way. If it's from the left, you would start over here and go this way. If you have the negative, that's the limit from the left. And then if you see a limit where you do not have a plus or a minus after your number, that's the limit from both sides. And remember, in order for this limit to exist, the limit from both sides to exist, the limit from the left and the limit from the right have to be the same. Okay? If they are different, if your limit from your right is 7 and the limit from the left is 2, then this limit right here at 3 does not exist. Okay, so let's look at the first graph that you've got there. All right, the main thing that you have to remember for this is that your we might want to write it down. Answers are always y values. Okay, so answers are always y values. So anytime you're trying to figure out what the answer is, you're looking at the y value that goes with it. Okay, so for example, the very first problem we have, the limit as x approaches 1 from the right of f of x, and this graph here is f of x. So x equals 1, if I can get my highlighter up here, x equals 1 right here. All right. And so what I want to do is I want to look at the value of this. Oops. Well, I can't make that little cursor right there move like I want to, so I'm going to have to. So from the right, it's like you started over here. Oh, no. It's still not working. Hold on. All right, so it's like you start over here, and you're approaching from the right. So as you get closer and closer and closer and closer to that vertical line, because that vertical line is where your x equals 1, what is the y value getting closer to? What is the y value that goes with that point right there? It is 1. Okay. Okay. Then I need the limit as x approaches 1 from the left. So I'm tracing my function from the left. I'm going to get closer and closer and closer and closer to 1. I don't actually get there. What's the y coordinate there? Same point, right? Still 1. So since the limit from the right and the limit from the left are both 1, the limit as x approaches 1 is also 1. Okay? Because those 2 points meet, that limit exists. Now, it's not continuous. It has a hole in the graph right there. But you can still have a limit because from the left and from the right, you're getting closer and closer and closer to that same point. So that limit is still there, but it's not actually defined at that point, or isn't continuous at that point. Now, what about f of 1? Okay, f of 1. Oops. Sorry, having trouble here. All right, so f of 1 is the value of the function at 1. It's where you have the closed-in dot. So for this, at 1, you have a open circle right there where the two sides meet. So you got a hole in the graph. What is the y value of the function at 1? Where is your closed-in circle? Always a y value you're reporting. That y value that goes with that is 2. So f of 1 is 2. Okay, questions so far? All right, let's look. I'm going to erase all of my doodlings here. Let's look at the next 4 problems. Okay, so the next one asks us to look where x equals 2. So whenever you're looking at an x value, there's always like a vertical line where x equals that value. So like right here is our x equals 2 line. Right? So what we're thinking about is we're thinking as we approach this line, as we get closer and closer and closer and closer and closer to this line from the right side, what's the y value? So, and you can think of like plugging in your calculator. 2.5, 2.1, 2.01, 2.001, right? Because at 2, we can kind of see there it doesn't have, we've got some problems at 2 because we have all that open circles and jumps and stuff like that. So what we're looking at is we're starting over here. We're tracing. We're getting closer and closer and closer and closer from the right. What is the y value of that point there? 3. So our limit here is 3. All right, so looking at the same point at 2, but coming from the left, this time as we approach from the left, what y value do we get close? For that to change, what y value do we get closer and closer and closer to? It won't let me highlight that. What is that y value? It is 2. No, it won't let me highlight what I'm wanting to highlight there. It won't let me write. It won't let me do anything that I want to do. So it approaches 2 there. That's our y value. Okay, always make sure you're reporting the y value, not the x value. It can get a little confusing, but if you just remember, you always have to give the y coordinate, then that helps. Okay, so at 2, if we're coming from both sides, our limit is different. So whenever that happens, we're going to say the limit does not exist. Most students usually want to shorten this down to DNE, and that is fine with me. If you want to put DNE for that, does not exist. Okay, so if the limit from the left and the limit from the right are not the same, your limit is going to be does not exist. And then for the last part, for f of 2, if we look back up here at the graph, when we're asked for f of 2, we want to know where the closed-in circle is. So the closed-in circle is right here. What is the y coordinate of that closed-in circle? 2. So f of 2 is 2. Okay, questions? Okay, let's look at the next one. Okay, so for this one, the first thing that it's going to ask is f of -1. So f of -1, we're looking right here. Where is your closed-in circle? What is your y coordinate? This one is a little tricky because it's not right on grid lines. What would you estimate it to be? Like 1.5? I will try on quizzes and tests to give you numbers that are exactly on the grid lines. If I do not, then an estimate will be perfectly fine for that. But I think most everything I have for quizzes or tests here is going to be, and in fact, we will not have a quiz on this. We're going to have a test on Thursday. Most everything I have, I think, has got perfect grid line answers there. All right, so then if we're looking at the limit as x approaches 0 of f of x, okay, sometimes this messes kids up right here because at 0, if you're looking at x equals 0, x equals 0 is right here. And so if x equals 0, then we're approaching that green line right there. Does it look like anything interesting happens at x equals 0? It does not. That actually makes the problem easier. So at x equals 0, right there you got the value of 2. It's continuous at that point. So from the left it's going to approach 2, from the left it will approach 2, from the right it will approach 2, and f of 0 will be 2. So everything is 2 if it's continuous there. So we are just asked about finding f of 0, which is 2. Okay. And then f of 2 from the right. So f of 2 from the right, okay, right here is where we have 2. We are approaching from the right, so we're going to start over here and approach from the right. What does it look like the y coordinate is there? -3. Okay. Questions so far? All right. Then it asks us about f of 1. So f of 1, we're looking at vertical line right here at 1. What is the y coordinate of f of 1? Okay. What will it be? It's 3, because we're looking at this closed-in circle up here at the top. The limit from either side is not going to be 3, but that closed-in circle is going to be 3. So for that, we would get we 3. Now, if we're looking at that same place that I have highlighted in blue, at x equals 1, now ask for the limit as x approaches 1. So if I were to look at that graph, and I'm looking as I approach from the right, what's the y value that we approach? 1. What about from the left? 1. And since they're the same, the limit as x approaches 1 here is 1. So even though f of 1 is 3, the limit is 1. This function's not continuous because it's got a hole in the graph there. But it does still have a limit because from either side it approaches that same point. And then our last one is the limit as f of x, limit as x approaches -1 of f of x. So -1 we had actually already highlighted here. It's in yellow, that vertical line highlighted in yellow. From the right, as we approach, what y value do we approach? Okay, so if we're approaching -1 from the right, what y value do we approach? We're going to this point right here, which has a y coordinate of 3, right? But from the left, I trace here, from the left, as I get closer to that vertical line, what y coordinates do I approach? So we're talking about this point right here. What's its y coordinate? 0. So since from the left I get from the right I get 3, and from the left I get, oh wait, this one asked for left. No, it didn't. This can be confusing. I'm messing myself up here. Is this one from the left? No, why not? The negative is in front. So we're looking at -1, but there's nothing behind the 1. So this means both directions. And since I got 3 from one direction and 0 from the other, what do I say for that limit? Does not exist. You got to be really careful with these because all those negatives and positives can mess you up. Yeah. Okay. Questions? Okay. We've got one more. Okay. So, let me see if I can just do this. It'll still show up pretty good. That's good enough. All right. So, the first question asks us about -2. So, always you're thinking about that vertical line at -2. I want you to, I don't have arrows on this because it's hard for this to be drawn. But even though they're not drawn there, this has an arrow right here, and that goes on forever, an arrow right here. Okay, so what does it look like we have right there at -2? A vertical asymptote. So if something looks like a vertical asymptote, assume it is. If you see something going up like that, assume that it is a vertical asymptote. There. So if I'm looking at the limit as x approaches -2 from the right, so we need to start on the right-hand side, and we're approaching that line -2. So we're starting here, and we're going this direction. What's happening to my y values? They're going up, 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 up. Are they ever going to get close to a number? They're just going to go up forever, right? So those y values get bigger and bigger and bigger. So what should I put for my answer there? Positive infinity. Now, I do need to put something else here. Most of the time, I think they will report that as positive infinity. But it is also possible that they might put the answer as does not exist. Because technically infinite limits do not exist. They will not have both of those as an answer choice, because for those you will not have both because they are both true. Because if you have a limit of infinity, that's like going down the road and seeing a speed limit sign that says speed limit infinity, right? It's not really a limit. So you might see either one of these, but I think they'd probably do the more specific positive infinity there. If I'm looking from the left of that same point, so the limit as x approaches infinity from the left, I'm starting over here. And I'm going to do this. What's the answer going to be for that one? Negative infinity, because those y values are getting lower and lower and lower and lower. Or possibly does not exist, but. Alright, so now for 1 and 2, you might see positive infinity or does not exist. For 2, you might see negative infinity or does not exist. What about number 3, the limit as x approaches negative 2 of f of x? That has to be does not exist. Because from the left and from the right, they don't go to the same infinity, right? Positive infinity, negative infinity. So that has to be does not exist. Okay, I'm going to erase this so that we can see the other stuff more easily. All right, our next problem is f of 4. So we're looking at where x equals 4, and we're just looking for where we have the closed end dot. So what is the closed end dot? Its y coordinate would be 2. So our answer here would be 2. The next problem is asking for the limit as x approaches 2. So we are looking here, and this does not have a plus or minus, so it means from both sides. So from the right, what y value do we approach? Looks like 0.5, we'll estimate here. What about from the left? The same point, because they touch there. So for this, we would say that 0.5 is our limit. What is f of 2? What are we looking for f of 2? Like the closed end dot, right? Is there one at 2? It is not. So this is a little bit, the vocabulary here can be a little bit tricky to remember because you want to say, you're doing all these limits, you want to say does not exist. We actually call this undefined. So if it's asking undefined, you would never use for a limit. Don't use undefined for a limit. A limit always does not exist. The value of the function is undefined. Okay, so if you're doing f of 2 and it doesn't exist, you're going to use the word undefined. If you have a limit and it doesn't exist, say does not exist. Okay, questions? All right, I'm going to erase that so that we can see the next part. Okay, f of 0, for f of 0, we're looking for the closed end dot. What's the y value of it? It's 4. Okay, what is the limit as x approaches 0 from the left for this one? From the left side, you're going to approach that open circle there. What's its y coordinate? About 0.5. And then 0 from the right. Or no, I'm sorry. That doesn't have a plus sign behind it. So just 0. What is our limit as x approaches 0? It does not exist. Because from the right, you approach 4 here. And so if those two aren't the same, then you will not have a limit there. You'll notice anytime you have a jump in your graph, the limit does not exist. At least if you're talking about the limit from both sides. pretty much a limit from one side should always be something. But a limit from both sides, if you've got a jump in the graph, it's going to not exist. And a hole in the graph, it will exist. Okay, questions? All right. I'm going to give you a worksheet. I think that you should be able to get most of this worksheet done in class. This worksheet, I'll say it is homework if you don't get it done, but I think you should be able to get it done in class. Your real homework is I have posted the beginning parts of tomorrow's notes on Canvas. It's not the whole set of notes. It's just like the first part, so that tomorrow we can like start with the ones that are. I tried to do the easier part first. Tomorrow we'll start with the ones that are a little more complicated, so we can get through it and get a little more practice in class. I think the video is like 10 minutes long. I know it's no more than 15. So your homework that I'll be checking tomorrow is really for you to have those notes. I'm going to check them both just to make sure you've got both. But the big thing I want to make sure that you get done tonight is those that video of the notes. If you know for sure that your internet access has not been doing so hot and you need to do that right now and work on this at home, that's okay. But otherwise, I would like for you guys to do this. The answers are on the back, so you can check your work as you go.